Find the derivative of g of x equals the fourth root of tangent of 3x plus secant of 3x. G of x here is a root, a fourth root in particular, of an entire expression. Tangent of 3x plus the secant of 3x. Since we have a root, it's going to be best to rewrite that as a fractional exponent. We have a tangent of 3x plus the secant of 3x, and the entire thing to the first power and fourth root, so 1 over 4 power. Since the 1 over 4 power is the outermost function, the derivative will start with the power rule, with that power of 1/4. Let's bring the 1/4 down, leave the inside alone, so tangent of 3x plus secant of 3x. We're going to subtract 1 from the power, so we will have 1 over 4 minus 1, I will call that 4 over 4. But since the inside of that power was not just an x, but rather an entire expression, we have to multiply by the derivative of the inside for the chain rule. Now the inside is all of this. And all of that, since we have two terms that are added, we can run those independently, but we have trig functions. The derivative of tangent is secant squared, leave its inside alone. But the inside of the secant and the tangent are not just an x, they are actually a 3x, and the derivative of 3x is a 3. We have to take a second chain rule. That 3 does not multiply the 3x, it will move to the front of the secant squared. The next term, the secant of 3x, the derivative will be the secant tangent, secant of 3x, tangent of 3x, so you leave the inside alone, and now multiply by the derivative of the inside being a 3x, the derivative of that is a 3. And that, for the same reason, will move to the front. It does not multiply the 3x's in the trig functions. So we had a double chain rule here, since what we had were 3x's inside of trig, which itself was inside of a power. The power went first, then the trig, and then the derivative of the inside of the trig. Double chain rule. All right, let's just simplify this a little bit here. So g prime of x will be 1/4 tangent of 3x plus secant of 3x raised to the 1 minus 4, so negative 3 over 4. And then we have, let's move the 3 to the front, 3 secant squared of 3x plus 3 secant of 3x tangent of 3x. The next thing is to move that negative exponent to the denominator. There's already a 4 in the denominator in the 1/4. It'll move down there with the 4. So g prime of x can now be written as, the numerator will be 1 times this entire expression. 1 times that is that, so I would just have that in the numerator. So 3 secant squared of 3x plus 3 secant 3x tangent 3x. And all of that is divided by 4 times tangent of 3x plus secant of 3x raised to the positive 3/4 power. So there's our derivative g prime of x. We do have an optional way to write this since we can factor the numerator a little bit. So let's write the factored version as well in case that's an answer you want to give. We have a 3 and a secant of 3x that can factor out. And that will leave us with a secant of 3x plus a tangent of 3x. And all of this over that same denominator. The denominator cannot be simplified any further, so just over 4 times the tangent of 3x plus the secant of 3x, and then quantity to the 3/4 power. So there's two different ways to write the derivative g prime of x.